Hello, I am Dr. H.P. Mandal, an Assistant Professor of Electronics and Communication Engineering Department of Dibrugarh University Institute of Engineering and Technology, Dibrugarh University. Today, I shall discuss about an emerging topic which is Semiconductor Overview and Future Trends in India. These are the outline of my presentation. First, I will discuss about the introduction of semiconductors. Followed by this, semiconductor industry landscape, growth trends of semiconductor in India. After that, current challenges faced by the semiconductor industry in India and government initiatives taken to enhance the semiconductor industry and research and development scenario, opportunities and future outlook of this industry in India, and finally I will conclude my presentation. So now, introduction to semiconductor. So now, definition of semiconductor. If we see, semiconductor are materials with electrical conductivity between that of conductors and insulator. Semiconductor have properties and allow their conductivity to be altered under certain conditions, making them crucial components in electronic device. There are a lot of devices or components are made with semiconductors, which are diodes, transistor, field effect transistor, metal oxide semiconductor field effect transistors, unijunction transistors, and many more. If we look the importance of the technology, so there are several fields will come into the picture. First one is computing and information technology. Semiconductor form the core component of CPU, enhancing the processing power necessary for computers and servers. Furthermore, semiconductors are used in various type of memory, including RAM, ROM, crucial for storing and retrieving data. Storage devices like SSD and flash memory offering faster data access and improved readability compared to traditional hard drive. So not only computing and information technology, also semiconductor has a remarkable role in communication industry also. In mobile device, semiconductor are essential component of smartphones, enriching wireless communication, data processing, and multimedia capabilities. In the telecommunication infrastructure, semiconductors, power routers, switches, and base stations facilitating communication network for voice and data transmission. Also in Internet of Things, semiconductors enable connectivity and data processing in IoT devices, ranging from smart home appliances to industrial sensor. Not only the communication and computing, also in the entertainment and multimedia, for audio and video processing, semiconductors are used. They are digital signal processor and graphic processor, GPU, that enhance the multimedia experiences. Also, in the automobile industry, semiconductor is used. Advanced driver assistance system, semiconductor enable features such as collision avoidance, adaptive cruise control, and lane keeping assistance in modern vehicle. Also in electrical vehicle technology, semiconductor plays a crucial role in power management, motor control and battery monitoring system in electric and hybrid vehicle. Also in the healthcare, medical imaging, semiconductor power imaging devices such as MRI and CT scanners, enhancing high resolution medical diagnostics. In industrial and manufacturing, automation and robotics, semiconductor drive automation and robotic system in manufacturing process, improving efficiency, precision and safety. Also in the industrial IoT, semiconductors facilitate connectivity and data analysis in industrial environments, enriching predictive maintenance and optimization of operation. If we see the history of the semiconductor, first it will come into our mind that role of semiconductor in modern technology. So first is invention of transistor in 1947. It is first transistor invented in Bell Lab, and this device was capable of amplifying and switching electronic signals. This marked the beginning of solid state electronics and replaced vacuum tubes. In 1958, integrated circuit known as IC invented. This IC technology allowed multiple electronic components to be fabricated on a single semiconductor chip, leading to smaller, more reliable and cheaper electronic devices. Furthermore, late 1960s, MOSFET transistor, the metal oxide semiconductor field effect transistor, was developed, offering better performance and scalability compared to earlier transistor technologies. MOSFET become the fundamental building blocks of modern digital circuits. Another important and interesting one, in 1965, Jordan Moore, co-founder of Intel, observed that the number of transistors on integrated circuits doubled approximately every 2 years. Moore's law became a guiding principle for the semiconductor industry, driving continuous achievements in chip performance and density. After that, in 1970s, microprocessor invented. The development of microprocessor such as Intel 4004 and 8008 brought revolution in computing by integrating the central processing unit onto a single chip. Within the period 1970 to 1980, DRAM and SRAM, dynamic random access memory and static random access memory technology were developed, providing fast and efficient memory solution for computers and other electronic devices. Other interesting, in 1980s, CMOS technology invented. Complementary metal oxide semiconductor technology emerged as the dominant semiconductor fabrication process due to its low power consumption, high noise immunity and scalability. CMOS became the foundation of modern digital integrated circuit. In 21st century, nanotechnology and nanoelectronics continued miniaturization of semiconductor components lead to the development of nanoelectronics, where devices are constructed at the nanometer scale. This includes technologies such as FinFET and nanowires, enriching further improvements in performance and energy efficiency. Finally, in quantum computing, semiconductor-based quantum computing is rapidly advancing field aimed to harness the principle of quantum mechanics for ultra-fast and powerful computation. Major players like IBM, Google, and Intel are actively researching and developing quantum processors using semiconductor technologies. So now we will see how the semiconductor industry has grown and evolved over the years. As already discussed, in 1940 to 1950, the semiconductor industry emerged in the late 1940 with the invention of transistor at the Bell Labs in 1947. Companies like Bell Lab, Texas Instruments, and Fairchild Semiconductor played important role in developing early semiconductor technologies. In the period 60 to 70, the invention of integrated IC in 1958. The 1960 and 1970 saw rapid growth as IC replaced discrete components, enriching smaller, more powerful and cheaper electronic devices. And also we have seen 1970 to 1980 microprocessor revolution. 4004 invented in 1971. In 1980 witnessed the rise of personal computer driven by the availability and affordable microprocessors and other semiconductor components. 1980 to 1990, the semiconductor industry became increasingly globalized, with companies establishing manufacturing facilities and R&D centers worldwide. Japan, South Korea and Taiwan as significant players in semiconductor manufacturing, challenging the dominance of American companies. 1990 to 2000, there was a revolution in internet and mobile technology. The rise of internet and mobile communication drove the demand for semiconductor components such as microcontroller, memory chips, and radio frequency devices. Companies like Qualcomm, Samsung gained prominence in mobile chipset and foundry services. In 2010 to present, the semiconductor industry has diversified to serve a wide range of applications including automotive, healthcare, artificial intelligence and Internet of Things. So if we see the semiconductor industry landscape, so now here we will see the overview of the semiconductor industry in India. The semiconductor industry in India plays a crucial role in the country's electronics manufacturing ecosystem and technological advancement. It encompasses semiconductor design, manufacturing, testing, packaging and research and development activities. If we see the market size and growth, India's semiconductor industry has witnessed significant growth in the recent years, driven by increasing demand for electronic devices and government initiatives. The market size is projected to continue expanding, fueled by rising investment, technological advancements and the adoption of emerging technologies. Major players in the Indian semiconductor industry include Intel India. They are involved to chip design, R&D and software development. Texas Instrument India engaged in analog and digital semiconductor design and manufacturing. Next, Qualcomm India. They are specialized in mobile chipset and wireless communication technologies. And Samsung Semiconductor R&D India. They are focused on semiconductor design and development. Additionally, there are several Indian semiconductor startups and design houses contributing to the India's growth and innovation. If you see the manufacturing infrastructure of India, so we will see India has made efforts to establish semiconductor manufacturing facilities to reduce dependency on imports and promote domestic production. The government's initiative such as Electronics Manufacturing Clusters EMC scheme aim to boost semiconductor manufacturing infrastructure in the country. And in research and development, India boosts a vibrant ecosystem of semiconductor R&D institutions, universities and research laboratories. Collaboration between academia, industry and government fostered innovation and technology development in area like VLSI design, embedded system and semiconductor material. So now these are the government initiatives and policies. The India government has launched various initiatives to support the semiconductor industry's growth, which are Make in India first, encourage domestic manufacturing and investment in the semiconductor sector. Second, this National Policy on Electronics NPE aims to promote indigenous production of electronic goods including semiconductors. Production linked incentive PLI scheme provides financial initiatives to boost semiconductor manufacturing in India. So there are several challenges and opportunity for the semiconductor industry in India. And if we see challenges facing in India semiconductor industry, which are infrastructure limitations and high cost associated with semiconductor manufacturing, skill gap and need for specialized talent in semiconductor design and manufacturing. However, there are significant opportunities for growth, the innovation driven by increasing demand for electronic devices in India and globally. Focus on emerging technologies like artificial intelligence, Internet of Things and 5G, which require advanced semiconductor solutions. Growth trajectory of the semiconductor industry in India. Early development in 1990s to 2000. In 1990s, India began laying the groundwork for its semiconductor industry, focusing on semiconductor design and R&D. Companies like Texas Instruments and Intel established their presence in India, setting up design and development centers. The government initiated policies to encourage foreign investment and promote indigenous semiconductor R&D also. Emergence of design services, which was in between 2000 to 2010, in early 2000 witnessed a surge in semiconductor design devices services in India, with numerous startup and design houses entering the market. Indian companies capitalized on the growing demand for semiconductor design services globally, offering low-cost solution and skilled engineering talent. And from 2010 to present, if we focus on manufacturing, in 2010 there was a shift towards promoting semiconductor manufacturing in India to reduce dependency on imports and boost domestic production. The government launched initiatives like the Electronic Manufacturing Cluster (EMC) scheme to increase semiconductor manufacturing investments. Several semiconductor companies, including global giants like Intel and Samsung, expressed their interest in setting up semiconductor fabrication laboratory in India. If we see the market size and revenue projections in semiconductor industry in India, the semiconductor industry in India has been growing, but specific market size and revenue projections might vary depending on the source and the current economic climate. Current market size, the Indian semiconductor market size is estimated to be in the range of several $billion annually, with contribution from various segments including design services, manufacturing and research and development. If we look the growth trend, the semiconductor industry in India has been experienced a steady growth driven by factors such as increasing demand for electronic devices, government initiatives to promote domestic manufacturing, and investment in technology infrastructure. The growth trajectory is expected to continue, supported by emerging technologies such as artificial intelligence, Internet of Things, and 5G networks, which require advanced semiconductor solutions. And if we look the revenue projection, while specific revenue projection can vary, industry analysts and market research firms may offer estimate based on the factors such as historical growth rates, and a lot of parameters are involved for that. Revenue projection for the semiconductor industry in India may be influenced by various factors such as semiconductor manufacturing investments, technology adoption rate, and global market dynamics. So few factors contributing to the growth of semiconductor industry in India. So several factors contribute to growth of the semiconductor industry in India. Among them, first one is government initiatives and policies. Already I have explained that Make in India, PLI, EMC, NPE, these initiatives, these are the schemes. These initiatives provide financial incentives, tax benefits, and infrastructure support to attract investments and foster growth in the semiconductor sector. Increasing demand for electronic devices, that is also the factor which is contributing to the growth of semiconductor industry in India. India's growing population, rising income, and expanding middle class have led to increasing demand for electronic devices such as smartphones, laptop, tablets, and consumer electronics. This demand drives the need for semiconductor components and technologies, creating opportunities for domestic production and innovation. So there are several points are there, several important key factors are there which contributing to the growth of the semiconductor industry in India. So another point is rising investment and foreign collaboration. Along with this, skilled workforce and engineering talent, emerging technologies and application, and we are more focused on research and development, and also we are focused to infrastructure development and support ecosystem. The Indian government's focused on infrastructure development including semiconductor fabs, testing facility and technology parks, creates a conducive ecosystem for semiconductor manufacturing and innovation. Access to state-of-the-art infrastructure, logistics and support service enables companies to establish and scale semiconductor operation in India, driving industry growth. Also, the global supply chain integration also one of the important point. India's integration into the global semiconductor supply chain through partnership, collaborations and participations in international trade agreement facilitates access to technology, markets and resources. Collaboration with global semiconductor players enhance India's competitiveness, technology adoption and foster industry growth. So now, along with the development, growth, also we are facing some challenges. The semiconductor industry in India faces several challenges that impact its growth and competitiveness. So there are several points. Limited manufacturing infrastructure. India lacks a robust semiconductor manufacturing infrastructure, including fabrication facilities, fab labs, and advanced semiconductor manufacturing process. The absence of indigenous fabrication labs forces Indian semiconductor companies to rely heavily on imports for semiconductor chips, leading to supply chain vulnerabilities and higher cost. High capital investment and operational cost is also there in our country. Setting up semiconductor fabs requires significant capital investment, and operational costs are also very high due to factors such as electricity, water and labor expenses. The high cost of establishing the operating fab labs in India poses a barrier to entry for domestic and foreign semiconductor companies. Another cause is skill shortage and talent gap. Despite having large pool of engineering talent, there is a shortage of skilled professionals with expertise in semiconductor design, fabrication, testing and R&D. The semiconductor industry requires specialized skill in areas such as VLSI design, embedded system and the semiconductor materials. Dependency on import and global supply chain disruptions. Regulatory and policy bottleneck. Regulatory bottleneck is one one of the major cause. Infrastructure and logistic challenges is there, and competition from the global players is also there. Indian semiconductor companies face stiff competition from established global player with advanced technology, economic of scale, and extensive R&D capabilities. Competing with multinational semiconductor giants require Indian companies to innovate, differentiate, and reach to market to remain competitive. The research and development activities in the semiconductor industry in India play a crucial role in driving innovation, technological advancement, and competitiveness. So there are some overview of R&D landscape in Indian semiconductor industry. So these are academic and research institutions, public sector research organizations, such as Indian Space Research Organization (ISRO), Defense Research and Development Organization (DRDO), and Council of Scientific and Industrial Research (CSIR) undertakes semiconductor R&D projects in collaboration with the industry partner and academic institutions. These organizations contribute to technology development in the area like microelectronics, MEMS, microelectromechanical system, and semiconductor materials. In India, institutions like Indian Institute of Technologies (IITs), Indian Institute of Science, Education and Research, and Indian Institute of Science (IISc) have dedicated departments and research center focused on semiconductor materials, devices, and systems. There are several private sector R&D centers. Several multinational semiconductor companies have established R&D centers in India and in India and expertise in semiconductor design and engineering. These R&D centers focused on chip design, verification, validation, and system integration across various semiconductor domains such as digital, analog, mixed signal, and RF radio frequency. Also in India, there are several semiconductor design service companies. Indian semiconductor design service companies contribute significantly to R&D activities by providing specialized design, verification, and validation services to global semiconductor companies. These companies undertake projects in ASIC, application specific integrated circuit design, FPGA, field programmable gate array, prototype, SoC designing, and IP development. Another important point in R&D sector is industry-academia collaboration. Collaboration between industry and academia is crucial for semiconductor R&D in India. Industry-academia partnership facilitate knowledge exchange, technology transfer, joint research projects, and talent development initiatives. Collaborative programs, workshops, and that bridge the gaps between academic research and industry requirements, fostering innovations and skill development. Government funded projects and initiatives, they are another important thing for research and development of semiconductor industry in India. The Indian government funds semiconductor related R&D projects through schemes like Semiconductor Technology Acceleration Center. In short, it is STAC, and the Semiconductor Research Initiatives (SRI). This initiative supports collaborative research, technology development, and infrastructure creation in semiconductor design, manufacturing, and testing. The focused area of R&D in India, it covers the wide range of areas including VLSI design, semiconductor materials, MEMS, NAMES, emerging technologies like R&D in emerging semiconductor technologies such as quantum computing, neuromorphic computing, and photonic integrated circuit. So now opportunities and future outlook of semiconductor in India. So there are several opportunities of semiconductor in India. For example, rising demand for electronic devices. Opportunities for growth and innovation in Indian semiconductor industry. Potential for investment and partnership. Role of startups and SMEs in driving innovation. Future prospect and outlook, if we see, government initiatives and incubatives. Government initiatives like Make in India, Production Link Incentive Scheme, Electronics Manufacturing Cluster Scheme, and National Policy of Electronics aim to promote domestic manufacturing, attract investment, and foster innovation in the semiconductor industry. Another important aspect is emerging technology adoption. Adoption of emerging technology such as 5G network, artificial intelligence, Internet of Things, augmented reality, and electric vehicles required advanced semiconductor solutions. Indian semiconductor companies can capitalize on these opportunities by developing specialized chip, sensors, and components to this application. And India has R&D ecosystem and skilled workforce and engineering talent is required, and diversification and niche markets. So this is in Indian semiconductor scenario, the Indian semiconductor companies can explore diversification into niche market such as automotive electronics, medical devices, aerospace defense, and industrial automation. Developing specialized semiconductor solution for these sectors can create new revenue stream and enhance India's position in the global semiconductor industry. Overall, the semiconductor industry in India holds immense potential for growth and innovation driven by the favorable market dynamics and government support, technological advancements, and a skilled workforce. With the right investment, policies, and collaborations, India can emerge as a leading player in the global semiconductor ecosystem, contributing to the economic growth, technological advancement, and job creation. Now, I would like to conclude my presentation. In conclusion, the semiconductor industry in India is for significant growth and transformation driven by various factors such as rising demand for electronic devices, government initiatives, technological advancements, and a skilled workforce. While the industry faces challenges such as infrastructure limitations, skill shortage, and global competition, there are massive opportunities for innovation, investment, and collaboration to overcome these obstacles. With the Indian governments focused on promoting domestic manufacturing, attracting investment, and fostering innovations in the semiconductor sector through initiatives like Make in India, Production Linked Incentives Scheme, and Electronic Manufacturing Cluster EMC scheme, the country is well positioned to establish itself a key player in the global semiconductor ecosystem. In the coming years, continued investment in semiconductor manufacturing industry and manufacturing infrastructure, research and development, talent deployment, and regulatory reforms will be crucial for realizing India's ambitions of becoming a leading semiconductor manufacturing and technology hub. With the right strategies and partnership in place, India can capitalize on emerging opportunities, drive innovations, and contribute to global technological advancements while fostering economic growth and job creation domestically. Thank you.